Alrighty, let's get back to this. Alright, so because like we were talking about, the LN is not for the 1/2, just this, so that makes this different. We're gonna expand it. This is why we needed to know about expansion. So how could I rewrite this?
1/2.
Yeah, not much to expand. 1/2 LN of x plus 5. Remember that? If it's an x, if it's the property for logs, if it's an exponent, you can bump it down in front to expand.
Couldn't we just do the regular log derivative?
It's just like chain, except you're not multiplying the.
You're
And it wouldn't even matter because you keep one.
the derivative, the difference between this one and this one, being that the whole function was being whatever, here, the whole function is not being, it's the x plus 5
But
that's
I'm saying,
being.
couldn't we do it like B, and it's just, it has a thing, so we just need to do chain rule? Put it on top, derivative on top, and then original on bottom.
There's not, let me think about this. Let me think about it. Chain rule would be, leave it and then times.
It'd still be the same thing.
I think it would. I think it would.
But only in this situation. What if it was 2x?
Hang on, we can check. So let's see, let's do derivative of this and then we'll check. Alright, so look, we got a constant times a ln. So we can say constant times now think about this. This is like if you had a constant times sine, the constant stays there and then you do derivative. What, same idea. So 1/2 derivative of this would be 1 over 1 over x plus 5.
Yeah.
Derivative over of that, okay. So that means this would be 1 over,
2x plus 10.
yes. Now, I'm gonna go with Tanner's thought, because I'm really not sure. And he said, what if we left it like this and did chain? Let's just see. It might, I just hadn't thought about it. So it would be 1/2 ln of x plus 5. What?
Tom, where'd you get the ln of x? I thought we'd just leave off the ln of x.
Here's the issue, and this is probably the answer to this question. Because you do in chain rule, you drop it down, you subtract 1, and this stays the same. Then your times derivative. That answers our question.
So why didn't we?
One thing.
It's because chain, you leave it alone, and then you multiply by derivative. So we would have a ln something in there
But
still.
I thought we just take the derivative of the whatever is not ln. And so you basically just cover.
I got you, okay, I got you, let me try that. So help me think. That would be 1/2 times
x plus 5.
I got you. Wait, no, not x.
Yeah,
Yeah.
I would. No,
It's
1.
just like for chain,
Yeah,
you just derivative of the outside time will keep the inside.
okay,
Then derivative of the inside to the negative 1/2, so it would.
To the negative 1/2.
okay. And then it would be,
1.
so the same?
Yeah,
All
it's the
over,
same.
all over x plus 5 to the 1/2.
Well,
Yes, because you gotta put the original on the bottom.
that's right.
Yeah,
That's gonna be the issue, isn't
yeah,
it?
that's the.
That's the
If
issue.
it was
I
just
don't-
the.
I think it works. Because, a second,
I don't,
negative 1/2, second times
But
1.
maybe
I'd rather just do it
that-
the other way, it was so much easier.
yeah. There's something weird there.
Because,
You just bump it down.
Why do you wanna do something harder?
you just bump it down.
Because it's.
Yeah,
it's
but-
negative 1.
When you
But when
bump
you-
it down, it messes with the other x plus.
No, wait a minute.
Or the-
If you bump it down, that becomes 1.
Yeah.
So, okay. So then it would be, so maybe it does.
Yeah.
Okay.
It's just.
Here's what I was thinking, I was multiplying.
Me too.
I was multiplying 1/2 and 1/2. Am I right?
Yeah.
Okay, never mind,
Do.
never mind. All right, we'll watch, if we hit another one.
It works, but
Yeah, all
I was
right,
thinking of something, I was doing it.
yeah. All right, it worked, I just didn't know. All right, so here's one, definitely, we've got to do something with expanding here because it's too yuck by itself.
you're right.
Thank you. Okay, so let us first expand.
Use
All right.
track.
All right, you start at the top and work your way. Okay, so this will be, and remember when you expand, every time you put down, every time you plus or minus to the next one, you put ln on it. So this will be ln of x.
Wait,
Well, we're expanding this. We got ln of x
Plus.
plus, because it's times, remember? All right, times what? 2 ln of,
X.
Okay.
now hold on,
Yes.
look. It's
Okay.
ln of x plus, from times, 2 drops down, 2 ln of this. And remember we said when it's all kind of in a chunk together, we just kind of bring it like that. All right, then, not over,
Minus.
minus,
Parenthesis,
Parentheses 2x.
ln.
oh, whoops.
1/2 ln.
Yeah, let me fix that. 1/2 ln parentheses.
2x. Why would
Do we do, no?
Because this was really that, and then, so we bumped, it was an ln, so we could bump it down. Okay, so there's the expanded, so this is what we're gonna take derivative of. Now it's easy. Because we'll do, guys, y'all with me? Now it's easy, because now we got it in parts. So we'll do derivative, derivative, derivative. So,
1 over x.
alright,
Wait, where?
1 over x
Oh, we can.
plus
plus 2 times,
2x
Wait, yeah,
over
okay.
x squared
2 times.
plus 1.
minus,
1/2
times
6x over 2x
6x squared over,
2x
Okay, why do we keep the 2 in the?
Oh, yeah, because we just,
Go ahead.
the u and u prime.
What'd you say?
I said, why do we keep the 2, like, whenever you find derivative?
just like if it was 2 sine x, when you take the derivative, it becomes 2 cosine x.
Okay.
The same concept.
So that-
It's like a,
Okay.
it's part of the thing.
It's
Multiplied.
It's almost like you're treating, just like with sine and cosine and this ln, it's almost like you're treating that like a,
function.
or a variable, almost, you know? It's almost like you've got 2 times,
So we can keep that
variable.
coefficient.
yes.
So like every
Okay.
time you see an ln, you do the derivative over the original.
Yes.
I was confused there for, I was like, how did you
Yeah,
get
that's
x?
what
And then I was like, oh, wait a minute.
Okay, I didn't know. All right, so
Okay.
let's clean it a
I'm
bit. We got 1/2 plus,
Wait,
Oh,
4x
1 over.
over.
I'm just cleaning it up, 4x over that, minus,
1 over x
6x
plus x.
squared.
or I could do this, couldn't I? I could go,
Oh.
I mean,
I did.
Yeah.
all right, so 3x squared over,
Minus.
and that should be it.
So we don't have to solve for anything, right?
You don't, that would be ugly, common denominator, no, that should be it.
Okay. I like this better than.
I like this too. I'm sorry.
Can you just give me related rates again?
Now, we got one more.
Can we go back to simple differentiation?
Got one more. Now, here's a different case of, what's different about this?
There's no L's in here.
There's no LN, no
So we gotta
LN.
go. So
And
just find
this
the
is
regular
just, you can't have
derivative.
a undefined. But,
Just find
so-
regular derivative?
well, here's the problem. Regular derivative of this is ugliness. It's ugly. It's got chain,
Change it too low?
chain, quotient, chain. It's got quotient, it's ugly. So if you ever hit non-log problem like this, you can actually use logs to make it work for you. So in other words, here's what I'm proposing. You can take the log of both sides, because remember, anytime you got an equation, as long as you do the same thing to both sides, it's legal. So I take the log of both sides. So what I mean is, take the ln of this side and take the ln of that. As long as I do
So
it
you
to
would
both
just put it on both
sides,
sides.
do the ln of both sides.
Oh, you don't have to simplify or anything?
We will simplify, yes, I just didn't want to do too many steps here. But, so we're gonna expand right here, we got to. Alright, that's no worse than what we
Yeah,
had.
get caught up real quick.
It's fine, I'll wait.
We could have been doing this the entire time.
Yeah, now you know, now you can, yes. Okay.
Talk?
Do the top, okay, so starting on top, what would I have? So there's the top part, minus
One half X
1/2. Oh, whoops, yeah, I'm bad to leave my L in.
Okay.
That's it's not as bad as,
And then derivative.
and then we're gonna do each one. Now, look right here, derivative of ln of y.
Do we
One
take
over
one?
Y.
1 over y, what do we usually do when we take a derivative of a variable other than x?
dy
dx.
Oh, dear
That's the
Lord.
same.
Oh,
thing.
It's the same reason, because we're in x. Alright, now we've got derivative of this will be 2 times,
One over X minus
so this is derivative of this, minus 1/2 times,
never mind.
2x.
2x over x squared plus 1. Okay, I'm waiting. I was just waiting, okay. Alright, now let's clean this up before I tell you where we're going next with this. So we got 2 over x minus 2, and he says the 2's here go away, that's good. X over x squared plus 1, so not too bad. Alright, now, we are wanting the derivative here. So we want dy dx by itself, just like before, same idea. So multiply by y, both sides, to get rid of this. Y times that, y times that.
So do we distribute that?
Let me see if we even want to do that. No, leave it for now. Yeah, leave it out there. So dy dx equals that, but I'm not going to copy all that down because I'm going to tell you what we're going to do with the y. What do you think we're going to do with that y? We don't need to distribute it. Do we know what y equals?
Y equals.
Y equals the original problem.
That's it. So
Oh my god.
Oh,
that's it.
We plug in.
Plug in for y.
I don't have enough room in my paper.
I'm sorry.
hold on.
Okay. I might need new piece of paper.
Yeah.
This,
This is really what.
Because I'm about to start crying on it.
this is the meaning of life.
I resume my statement.
Right
This
here.
is just about equals what we had.
It's just a lot to do.
It is.
How long am I gonna? We better have like 3 hours to do this.
I know, right? Or,
And that's it. That's all we're.
oh, so that's it.
That's
Oh.
it.
I thought we had
So we
to
don't have
avoid
to
it.
simplify?
No, that
Oh,
is
Jesus.
that's the
What
other
about
good
the x
thing.
does not equal 2? Do we have to take that into consideration?
So glad.